Isomerism. Isomer. Iso means what? Same. Same. Mer means unit. Units, same units like that. So isomerism means compounds should have the same molecular formula, but different in their structure or the spatial arrangement. They're called as isomerism. So isomerism basically two types, Nana. So we are going to classify in the two types. The first thing is structural isomerism, stereoisomerism. So broadly we are classifying into two: structural isomerism. Second one is stereoisomerism. Right. Structure and stereo. So main important thing is compounds should have the same molecular formula, but different in their structure. And if the three-dimensional shape is different, those were called as stereoisomerism. So what exactly this isomerism? Why we have to study this? Right? For example, try to understand. One person is here like this. Right? One person is like this. One head, two legs, two hands like that. Now, physically handicapped. Actually, hand should be present here, but hand came here like this. So, both are having the same weight. Imagine, same head, two hands, two legs and everything. But the problem is, the structure. In the structure, it is different. So those were called as structural isomerism, simply. Right? In case of stereoisomerism, what exactly stereoisomerism? Anyone? Right. For example, this person is like this. One person is having the two hands like this. It's just keeping down. Three-dimensional structure is different. So the other person, same position, hands are there. Okay, but he just opened his hands. Okay. So the person, same hand, same position, same structure, everything is same. But for example, is standing like this one time is standing like this. Is there any change? Nothing, right? Same place and everything is same. For example, one small gate is there like this, small door. If we can go like this, no issues. For example, I want to keep like my hands like this. I want to go. Can I? No, I have to turn like this. Otherwise, like. So means isomerism means what? Try to understand. Structural isomerism, stereoisomerism. Broadly, we are classifying into two types: structural, stereo. Stereoisomerism means what? Compounds which are having the same molecular formula, but in the spatial arrangement is different. In the space, the arrangement of molecules are different. Those were called as stereoisomerism. Compounds which are having the same molecular formula. Right? With this structural isomerism, we could say constitution isomerism also. So, here is same molecular formula, but the entire structure is different. Right? In structural isomerism, once again, we are going to write chain, write it down, position, chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, and one more is there, that is nothing but ring chain isomerism. Ring chain isomerism. In stereo isomerism, no? Stereo isomerism. Once again, we are going to classify two types. Conformational isomerism. Conformational isomerism. Configurational isomerism. Configurational isomerism. This configurational isomerism, once again, two types. Geometrical, optical. Geometrical, optical isomerism. Chain, position, functional, metamerism, tautomerism, ring chain. Ring chain and functional isomerism almost are similar, right? Ring chain and functional isomerism. And stereo isomerism, conformational, configurational isomerism. And configurational isomerism, once again, geometrical, optical isomerism. Difference between structural isomerism and stereo isomerism. Structural isomerism, stereo isomerism. The first point is same. Both should have the same what? Same. Both the cases, same molecular formula should be present. Molecular formula should be same, both the cases. Next here is second point, connectivity. Connectivity between the atoms. Connectivity. Connectivity between atoms. Atoms are same or different? Connectivity. Huh? Different, right? Connectivity. So I told you, and is there one more and. Connectivity of atoms are different. In this case, connectivity of atoms same. Connectivity of atoms same. Write it down. Same. Connectivity between atoms are same. In this case, no different IUPAC name. Different IUPAC name. This case, same IUPAC name. Just cis and trans is just R and S, something is different, right? So write one more point. Isomer are molecules. Isomers are having the same molecular formula, but different physical and chemical properties. Right. So simply put the heading, structural isomerism. The structural isomerism, chain isomerism. Chain. Definition. All definitions are same. All definitions are same. Compounds which are having the same molecular formula but different in their chain. Parent chain also we could say. It's called as isomers. The phenomena were called as chain isomers and the phenomena were called as chain isomerism. So for example, this is what? N-butane. Yes or no? 1, 2, 3, 4. What nana? N-butane. So 4 carbons, but, all are single bonds, N-butane. What is the molecular formula? C4H10. C4H10. Now, for example, if we can write the same molecular compound, CH3, CH, CH3, CH3. So this is, we could say, isobutane. Isobutane or 2-methyl propane. So, or we can write 2-methyl propane. The people who are weak at the nomenclature, so please write it down. So that is the reason I am writing. So how many carbons here is? C4, 1, 2, 3, 4 and H10. So what is the same over here? C4H10, C4H10. Compounds which are having the same molecular formula, right? But different in their carbon chain or parent chain. So these two we are called as chain isomers. So how did you write that definition? Compounds which are having the same molecular formula but different in their parent chain or chain structure. The structure is different, right? Right. For example, write pentane, N-pentane, CH3, CH2, H2, N-pentane. Why I am writing the N-pentane means straight chain. Whenever the N we are writing, that would be straight chain. So each and every time whenever you are writing the isomers, write the IUPAC name. What is the formula? C5 alkane, right? No. Whenever the alkane, what is the general formula for alkane? CN H2N plus 2. C5 H12. 5 into 2, 10 plus 2. Obviously, so no need to calculate here. 12. Directly we can write the 12. Otherwise, 3 plus 2, 5, 7, 9, 9 plus 3, 12. Now, CH3, CH, CH3, CH2, CH3. Right? 1, 2, 3, 4. Right? What is the name? Isopentane or 2-methyl butane. So count the number of carbons. C5H12. C5H12. Here is also C5H12. CH3, CH2, CH. What is this name? Tell me. Both are same or different? 1, 2, 3, 4. Same. It seems to be the right. Both are same. Right. CH3, 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 H3. Neopentane. Neopentane is common name. 2, 2. So straight first always whenever we are writing the IUPAC nomenclature, first we need to select the longest chain and 2 methyl groups. 2, 2 dimethyl. Dimethyl propane. Any others are possible, no? Now in this case, how many are possible? Pentane. How many isomers are possible? Total 1, 2, 3. If they are giving this structure, if they are asking how many isomers means 2. For example, they'll give the question is C5H12 is having how many isomers means 3. For example, they gave the N-pentane, how many isomers it is having means we need to say 2. Because we no need to calculate. If they will give the formula for C5H12, how many isomers are possible means 1, 2, 3. Compounds are having the same molecular formula. Here are also C5H12. C5H12. Compounds have the same molecular formula but different in their structure. In these 3 structures, which is more boiling point? N-pentane or isopentane or neopentane. This is a very important 5-star. Put 5-star. I'll discuss this is in where? In hydrocarbons, alkanes, but I'm telling here, if it is having the more surface area, right? More attractions are there, more boiling points. Means directly we can say boiling point is inversely proportional to branching. This is very important. Boiling point is inversely proportional to branching. In this case, no branches. 1 branch, 2 branches. Now let me know which is more boiling point. N-pentane. Got it? More boiling point because less branching. Which one? N-pentane. Now C6H14. C6H14. Write down how many chain isomers are possible. Come on, do it. Tell me, let me know the number. Right or wrong, doesn't matter, try it. So 1, 2, 3, 4, 5, 6. I'm not writing the hydrogens. N-hexane. N-hexane. Now I'll make it into 5. 1, 2, 3, 4, 5. Okay. Here is one carbon. 1, 2, 3, 4, 5. What Nana? 2-methyl pentane. Isohexane. So, but 2-methyl pentane would be better. So, can I make it 3? Because this is coming to here. Cross check. So, 1, 2, 3. Write the name. Because when we are writing the name, so we'll get whether the both are same or different. Right? We'll get. So, 3-methyl pentane. We'll make it to one more. What? 4 carbons. 1, 2, 3, 4. So I'm just writing same. 2, 2, 1, 2, 3, 4. Longest chain. 2, 2 dimethyl butane. Next Nana. 1, 2, 3. 1, 2. 2, 3 dimethyl butane. I'm not writing the total. 2, 3 dimethyl butane. And can we put any ethyl group? 2 carbons same. For example, 1, 2, 3, 4. 2 ethyl butane. Is it possible? No, because longest chain. 1, 2, 3, 4, 5. 3-methyl pentane. 3-methyl pentane already we wrote here, right? It's not possible. So now how many? 1, 2, 3, 4, 5. 5 Nana. What is the answer? 5. So in this case also, sometimes 4 and 5 lot of people are confusing. Try to understand. If they gave the formula is like this Nana. C6H14 is given. Its the answer is 5. Chain isomerism not only in alkane. For example, in this case chain isomerism is possible. C4H8. For example, CH3, CCH3, double bond, CH2 Nana. C4, 6 plus 2, 8. C4, H8. 1, 2, 3, 4. What is this? But. So in this case, 2-methyl pro 1-ene. Both the cases 1-ene should be common chain isomerism. Position we won't change, right? If you are changing the position, it becomes position isomerism. I'll explain position isomerism also. But don't change the position. The position should be same, first place only. Put the heading position isomerism. So here also same definition wherever we are going. Compounds which are having the same molecular formula but different in their position. Position of what Nana? Position of double bonds or position of triple bond or position of functional group, right? Or position of substituents, etc. So those were called as position isomers. In the definition, compound should have the same molecular formula. Molecular formula should be same but different in their position. For example, try to understand. CH3, CH2, CH double bond CH2. So what is this name? But 4 carbons, but 1ene. But 1ene. So now C4 H8 molecular formula. Right? 5, 6 plus 2, 8. One more is also possible. What is that? CH3, CH, double bond, CH, CH3. No. So this is but 2ene, C4, H8. Compound should have the same molecular formula, but the position of the double bond is different. So those were called as position isomers. Write it down. Position isomer. In place of double bond place, we can take triple bond also. But 1,9, but 1, 2, 3, 4, 1, 2, 3, 4. Write it down. But 1,9, but 2,9. Write it down. For example, what is this name? What is this name? 1, 2, 3. 1 chloropropane. 1 chloropropane. Now in this case, 1, 2, 3. 2 chloropropane. So now position of the halogen is different. Now these two we are called as what? What no? Position isomer. Position isomer. Same we can take even alcohol. Like this. 1, 2, 3, 4. But 1 whole. 3, 4. But 2 whole. But 2 whole. But 1 whole. But 2 whole. So now let me know. Right now. See, Nana, 1, 2, 3, 4, 5, 6. Right? What is this name? Hexanoic acid. Hexanoic acid. Right? One hexanoic acid or hexanoic acid. We can, no issues. But in this case, 1, 2, 3, 4, 5. Right? 2 methyl. Pentanoic acid. Pentanoic. These two are what? Which isomers? Position. Where the position is changed. The COOH is first position. COOH in the first position only. These two are chain isomers. Chain isomers, not position isomers. These two are chain or position. 1, 2, 3, 4, 5. Right? Pent 1 all we can say. Right? Here 1, 2, 3, 4. 2 methyl. But 1 all. Both are which isomers? No? Chain isomers. Right. Both are chain isomers or position isomers. See, Nana. 1, 2, 3, 4, 5, 6, 7. This is what? 4-ethyl heptane. In this case, no? 1, 2, 3, 4, 5, 6, 7. Right? This is also 4-ethyl heptane. So both are what? Chain or position? Huh? Both are identical. No chain, no position. Right? This is called as illusion. This is propyl and this is ethyl. Right? So position is changing. Right? Both are. So these two are not isomers. Not identical, no chain, no position. Both are not isomers. Why? Because in this case, Nana, 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10. Total 10 carbons are here. C10. In this case, na, 1, 2, 3, 4, 5, 6, 7. 7 plus 2, 9 carbons. Molecular formula is not same, so how it would be isomers? Isomers criteria is what? What is the criteria for isomerism? Molecular formula should be same. Now let me know, this is chain isomerism or position isomerism? Chain or position? You never see this type of question. Write one more question. Chain or position number, right? So we will follow our technique, nothing but JN technique. Okay? JN number. What is J and what is N? J means what? J means parent chain. Parent chain. N means substituent. For example, if J and number is same, J and number both are same, J number and M number, that is position isomerism. If J and number is different, J and number is different, that is chain isomerism. Okay. So try to understand what is J number and what is N number. So J, I told you, for example, in this case, what is the parent chain? Means longest chain, of course, right? Hello, 1, 2, 3, 4, 5. 5 J number, parent chain. And substituents, how many substituents are there? 1. So 51. J number is 51 in this case. In this case, 1, 2, 3, 4, 5. So what is the J number? 51. So J number is same or different? If the J number is same, both are what? Position isomers. So whenever you are confusing between chain and position, that cases we need to use this JN number. Particularly, to come back to this one, first one. Now, how can we say the JN number, chain or position? So in the bicyclo compounds, I told you the how we need to give the parent chain numbering, right? Either we need to start the bridged carbons, of course, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So parent chain 10. J number. How many substituents are there? No. So means 0. In this case, Nana, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the J number and one substituent 91. This is 100, this is 91, JN number. JN number. So both are same or different? Different. Different means what? Both are which isomers now? Chain isomer. Clear everyone? In this case, it is very confusing. Chain or position? The second one. Now tell me the second one, everyone. 1, 2, 3, 4, 5, 6. 61. This is 61. This is 1, 2, 3, 4, 5, 6. 62. 61, 62. Come on. A and B. Chain isomers or position isomers. Anything is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11, 0. No substituents. So where we need to start the numbering is here. 1, 2, 3, 4, 5, 6, 7, 8, 10. Right? 10, 1, 1 at 1, 1, 1, 0. Both are same or different? Different. So, chain isomer. Write a question. Minimum number of carbon atoms are required. How many? How many? Write it down. How many? Minimum. How many minimum number of carbon atoms are required for an alkane to show chain isomerism, right? 2 carbons, it's not possible. 3 carbons, it's not possible. 4 carbons, it's possible, right? What is the answer? 4. Thank you.